Hello everyone and welcome back. So in this video we are going to deal with the coin change problem, which is nothing but a slight but a tricky variation of previously solved question, that is count the number of hops. So if you haven't watched that video, I highly recommend you watching it before this, because throughout this video we are going to compare and contrast the differences and similarities in our approach, solution, and even in the programming aspect, the way we are going to code the pro solution. So the problem says that given a value of n, we need to find the number of ways to make changes for n cents if we have infinite supply of each of s, that is s1, s2, all the way till sm valued coins. So it is saying nothing but we have certain currencies like we have in real world, 1 rupee coin, 2 rupee coin, 5 rupee coin, and we need to form a sum which is equal to n using those coins, and we have infinite supply of those coins, and we need to tell what are the unique different possible combinations to form that n valued amount. Let's better understand this. We have, let's say, amount equal to let's say 3. So we need to form amount equal to 3, and in our pocket we have coins of, let's say, 1 and 2. So the possible way is 1 plus 2 or 2 plus 1. But the interesting thing is both are the same way, and in total both these combinations should be considered as one way, because we are using just 1 plus 2, 1 coin of 1 and 2, 1 coin of 2. So we conclude that permutation is off in this question, that is nothing but order is not important. Whereas in the problem count number of hops, what we were supposed to do is we were supposed to find all the number of possible combinations or jumps that a person can take to reach the third step, let's say third step. So a person can jump 1 and then from there he can jump 2, or he can jump first 2 and then from there he can jump 1. Both are two different ways. We were considering them as different, and we were counting them as two different ways. We were considering permutations on order was important, but in this question it's no longer the case. So how do we approach? Let's take an example. Let's say we have coins 4 and 1, and the amount is, let's say we need to form amount of 5. Now I have taken the number small so that we can experiment and understand how we are going to develop our approach. So I have amounts over here and DP over here. This is the DP array. At the bottom is the amounts, and for the initialization I have taken DP0 equal to 1. So to reach 1 we have one way, to reach 2 we reach from 1, that is one way, reach 3 from 2, that is one way, 4 we will reach from 3, that is one way. But we can, instead of reaching 4 using 1 1 1 4 coins, now in fact what we can do is we can reach directly from 0, that is using the coin with currency equal to 4. And since 0 is dp0 is 1, we are just going to add it to our dp4 as well, that is plus 1. Now if we reach from 4, we have two ways, because we can reach 4 in two ways, and from if we want to reach 5 from 4, we have two ways. And in fact what we can do is, instead of reaching from 4 using one coin, we can reach to 5 using the 4 coin with 4 value, that is jumping from 1 to 5, and that will be one way. So I'll just list the combinations. I'm listing the possible ways to reach 5, that is 1 1 1 1 1, 4 comma 1, and 1 comma 4. So 1 comma 4 is we go from 0 to 1 and then 1 to 5. So we have the case 1 comma 4, and 4 comma 1 is the case that we go from 0 to 4 and 4 to 5. But both are the same ways, same cases. It's just the order that is different, and we are not valuing the order. So one way is that we keep track how many times the orders are the combinations are being repeated, but there is no way to keep track efficiently. So now, since there is no efficient way, we look for an alternative. So what we will do is, again we will consider the same case, but this time we are going to sort the coins. So how does that benefit us? We'll see in a moment. So now we will start from the first element in the sorted coin, and we will do nothing but dpi is equal to dpi minus coin, and coin is nothing but 1 for now. So what we have done is we started iterating from coin 0, that is 1. We started iterating, went all the way till 5, and for each element we did dpi is equal to dpi minus coin. Now when coin is equal to 4, that is coin is first element in the array, we start from 4 and we do nothing but dpi is equal to dpi minus coin. So dp4 is equal to dp4 minus 4, that is dp0. Therefore it is 1, it will be added plus 1. And for 5, let's do this before. So dpi minus coin is 4 minus 0, 4 minus 4, that is 0. So we add 1, that is the element in dp0, value of dp0. Now for 5 we have dp5 is equal to dp5 is equal to dp5 plus dp5 minus coin, that is 4, that is dp1, and dp1 is 1, so we add 1 to dp5. So we sort the coin, we iterate in the coin array, and we then come to the ith amount. We start iterating all the way till n plus 1, doing dpi is equal to dpi minus coin 0. Then we move to the second element of the coin. We start with coin as our amount and iterate all the way till n plus 1, and for each element we do dpi is equal to dpi minus coin. We are adding, actually it's not equal, we are adding, and in this way we have set our permutation off, whereas over here we were unable to set our permutation off. It was on and the order mattered. Now there might be a lot of confusion, but as we will program our approach, things will become a lot clearer. Now we have the program for counting the number of hops or count ways to reach the nth stair. The prerequisite will be you have a complete understanding of how this program works, and the fact that in this program permutation is on, that is order matters. Now what we are seeking to do over here is we are seeking to add minimum amount of adjustment or modifications to switch off the permutation, that is order, so that order does not matter anymore, and the program can then work for our coin change problem as well. Let's start with correcting the variable names for better understanding. Allowed jumps will be coins, that is the number of coins, the currency values we have available. We will sort that array and we will switch the inner loop with the outer loop. So we no longer have any array with the name allowed jumps. In fact, we have renamed it to coins. So I'm going to rename it here as well. And we will be iterating in the now inner loop starting with j, which is nothing but the element in the array coins. Let's program it on the editor. We are going to modify this code starting with changing the function name. Now we are going to call it coin change instead of count ways. Makes more sense. And now I'm going to comment the allowed jumps array because it is no longer being used. And instead of passing just n as the parameter to the coin change function, we will also add a parameter coins, which will be user defined, that is the coins of currency we have. Let's say For example, we have coins of 1 rupee, 2 rupee and 3 rupee, and we want to find out the number of ways to obtain the sum of or the total amount of 4 using infinite supply of 1 rupee coin, 2 rupee coin, 3 rupee coin. So we do want the coins array to be sorted. So even though it is sorted in this example, anyway we will sort the array, and in the initialization we just need dp0 equal to 1. We are no longer certain about what dp1 will be. So dp0 is equal to 1, that is by convention, and we are going to keep that initialization true. We have dp of n plus 1 length, and now as we have already discussed, first of all I'll change the array name over here also to coins, and now as we have discussed, we are going to switch the inner loop with the outer loop. So now I have switched it, and instead of calling j in coins, I'm going to call it coin in coins, and the inner loop will start iterating from coin, and it will be dpi minus coin, just replacing j by coin everywhere. And now I will run this program, and the program returns me 4, which was expected. So our program is working right, and we have solved this problem. All we did, we took the previously defined program for the problem where the permutation was on. We made minor adjustments so that the permutation got turned off. We saw the visualization how our new approach was able to cope with not considering the repeated cases, and this is it.